Hi guys, today our lesson is on quadratic equations, and in particular we will be learning how to find the maximum or minimum value of a quadratic equation. Now if you were to graph a quadratic equation, you'd get a smooth curve called a parabola. Now as you can see here, the parabola can either have a minimum value or a maximum value. Note also that the minimum or maximum is determined solely on whether the a constant in the general expression is negative or whether that constant is positive. Here you can see that if a is positive, the parabola will have a minimum value, and if a is negative, the parabola will have a maximum value. Now here we have a typical parabola with a minimum value. Here I'm going to highlight a few important points on this graph. The first being the y-intercept, and this is where the graph cuts the y-axis. Secondly, we look at the minimum value of this graph, and the coordinates of that minimum value is another important point. We denote the coordinates here as xm and ym, where xm is a value of x which makes the function a minimum, and ym is the actual minimum value of the function. Lastly, two important other points are denoted here as x1 and x2, and these are called the solution of the equation or the roots of the equation. Recapping, you're typically asked in your exam to determine the y-intercept, which we have denoted here as c, the value of x which makes a function a minimum xm, the corresponding minimum value ym, and the roots of the equation x1 and x2. Now to find the y-intercept, we merely need to look at the general equation and set the value x to be equal to 0. By doing so, you note that the terms in a and b disappear and the y-intercept equal to c. So once we examine the general equation, the y-intercept is always equal to c. So how do we determine these minimum values? Well, the first thing we need to do is to change the general form into another form, which is y is equal to ax plus h all squared plus k, shown here in equation 2, where a, h, and k are constants. Now x is the independent variable which can assume any value. In one particular instant, for example, if we were to set x equal to minus h, notice that the term in bracket would actually go to 0, and the a term would disappear, leaving y is equal to k. So at once we see that at a certain value of x, and that is when x is equal to minus h, the term in bracket disappears and the value of y takes on its smallest or its minimum value. And in this case, we note then that the value of x which causes the function to be a minimum is when the value is equal to minus h. In this case, we will denote that value as shown before by xm, and the minimum value of the function ym is when that function is equal to k. Now to find the roots of the equation, we merely need to set y to 0 and solve the equation by transposition. Let us look at a typical example. Here we have a function y is equal to 2x squared plus 3x minus 4, and we're asked to find the y-intercept. We are asked to change the equation from the form y is equal to 2x squared plus 3x minus 4 into the new form y is equal to a into x plus h all squared plus k. We are then asked to determine the coordinates of the minimum value and the roots of the equation. Now, as stated earlier, we merely need to set x to 0 to get the y-intercept. In this case, the y-intercept is seen easily as being equal to minus 4. by setting x to 0, the other two terms will disappear. Now for item number 2, here we have to express the function y is equal to 2x squared plus 3x minus 4 into the new form y is equal to a into x plus h all squared plus k. Now to do this, we can use one of two techniques. We can either apply a technique known as completing the square to get the values h and k, or we can simply apply the formulas where h is equal to b over 2a and k is equal to 4ac minus b squared over 4a, which means you will need to memorize those two formulas if you are not fully conversant with the technique known as completing the square. In any event, we apply the formulas directly to get h is equal to 0.75 and k is equal to minus 5.125, giving our function in its new form y is equal to 2 into x plus 0.75 all squared minus 5.125. Now, once you have your function in its new form, you can find quite easily the values of the coordinates of the minimum for that function. As stated earlier, the value of x, which makes a function a minimum, which we denote as xm, is when the value of x takes on the value of minus h, and therefore xm is equal to minus 0.75, and correspondingly the minimum value of that function ym is equal to k, or minus 5.125. Finally, we find the roots of the equation, and here it is that we set the function y to 0 and we solve. Now, once we solve a quadratic equation, we will always get two values, and here the values are shown to be x1 and x2 as 0.85 and minus 2.35. If you were to sketch this graph, you would see clearly the important points that we found earlier. The roots of the equation shown here is minus 2.35 and 0.85. This is where the graph cuts the x-axis. Here we are showing the coordinates of the minimum value as the value of x at which that occurs, minus 0.75, and the actual value of the minimum, which is minus 5.125. And finally, here we see the y-intercept. This is typically how this is done. You may visit our website at any time to download more help content. See you next time.